Good afternoon, everyone. Welcome to English Medium Prep by Exam Port. And I'm Kumar Ravi. I'm here to discuss the theory concepts of electric current electricity. Okay. So today we will also discuss some important questions. Okay. So, guys, today we will study the current electricity, some topics from current electricity. Okay, and as we have already know that we have completed the resistivity dependency of the temperature on dependency of resistivity on temperature. How does the value of resistivity varies with the variation in temperature. Okay, so today we will see about that what kind of materials their resistivity changes. Okay, with the temperature. So there is one line actually that has to be discussed, because we have not discussed that thing actually yesterday. One question actually asked from this line actually. Okay, so today we will let me one thing tell you that uh, in case of semiconductors, if we increase the temperature of the semiconductor material, then the resistance decreases. Okay, so in case of semiconductor materials, in case of semiconductor materials in case of semiconductor materials resistance de- uh, huh, resistance decreases on increasing the temperature on increasing the temperature on increasing the temperature, electric resistance decreases. Electric resistance decreases. Okay, electric resistance decreases. So this is actually one of the most important thing, and hence temperature coefficient of resistor for the semiconductors is hence uh, the temperature coefficient of resistance temperature coefficient of resistance of semiconductors is negative. is negative. Okay, so alpha is negative. Alpha is negative for that. Okay, so alpha is negative for that. So this is the important thing actually. Okay, you will have to keep in mind that this question is asked in examinations. Okay, that alpha is negative for semiconductors. Alpha is negative for semiconductors. Alpha is negative for semiconductors. Okay, so this is like this. Alpha is negative for semiconductors. Okay. Alpha is negative for semiconductors. So these are the important points, and suppose that now we will study the electrical connections. Okay, so electric connections. So what are the electric connections? What are the electric connections? What are the electric connections? Okay, number one, yes, number one is series connection. Number one is series connection. Series connection. There are two types of electric connections actually. There are two types of electric connections. Okay, number one series connection and number two parallel connection. Number two parallel connection. Okay, parallel connection. Number two series connection. Okay, so when we will talk about the series connection, what will happen? Okay, in case of series connection, when we discuss series connection, then it will happen actually. Okay, oh, if we discuss the series connection, then it will happen like this. Then it will happen like this, that in case of series connection, two devices will be connected in series like this, and suppose that these are the two resistances. Okay, so suppose that these are the two resistances. Okay, this is 1 and this is 2, and suppose that the resistance R1 and this is the resistance R2. Okay, so this is the resistance R1 and this is the resistance R2. Okay, so suppose that this is the 1 and 2 terminals. Okay, and suppose that this is the first terminal and this is the second terminal. Okay, now this is the first terminal, this is the second terminal. So first and second, these two get connected like this. Okay, so these can be connected like this, and the second terminal of this second terminal of first and which is connected to the first terminal of second, and that is, and the such type of connection is known as the series connection. Okay, so in series connection, same current flows through the same current flows through all the devices. Okay, same current flows through all the devices, but uh, but the plus and minus. Okay, so plus and minus, you can see here, but the plus and minus. So this is plus and minus. this is plus and minus, and which is very very harmful. Sorry, this is very very here this is the plus and minus, actually, in which we will put the sign positive where the current is entering into the element, and where the current just leaves the element, okay, will be given as the negative. The current will enter at this terminal, we will give at positive, and at this point it will be given as negative. Okay, so it means there will be a potential drop. It means there will be a potential drop at the 2 points of an between the two terminals of a between the two terminals of an element. Okay, so this will be V1 and this will be V2. Okay, so V1 and V2 will be the two types of terminals. Okay, so now V1 and V2, suppose that here we will write it as yes, we will write it as same current flows, same current flows through, okay, same current flows through both devices, all the devices. All the devices. Okay, now but the potential across but the potential across the devices is different from each other, okay, is different from each other. So now we will here we can see that, here we can see that yes, we can see that V1 will be equal to, yes, so we will write it as the total voltage across both the devices will be total voltage across both the devices will be like this. Okay, so the total voltage across both the devices will be V, and V will be equal to V1 plus V2. Okay, so this will be equal to capital I into R. Suppose that the total resistance is R, then this will be equal to I into R1. Okay, I into R1 plus I into R1, because current is same. Okay, so we will write it as, so here we can see that the resistance becomes R1 plus R2, and hence we can see that this R is equal to R1 plus R2. R is equal to R1 plus R2. So here we can see that the R will be equal to R1 plus R2. So this is the total resistance of all the resistances which are connected in series connection. Okay, so here this is the correct answer. So this is the very important result, and which is very very important. Okay, so this one is the series connection. Actually, as I have already told you that in case of series connection, the current remains same in all the devices, but the voltage across the terminals of the devices is different from each other. Okay, so this is the method. Okay, so this is the method how can we find out the net resistance of the circuit. Suppose that I have seen so many questions in the different examinations in which two or more than two resistances two or more than two devices are connected in series, then the question asks to calculate the net resistance offered by the circuit. If it is so, then we just need to calculate the total resistance by just adding them simply, because the effective resistance offered by the circuit will be equal to the sum of the effects, sum of the resistances of all the devices combine them, and this will be the correct answer. Okay, but in case of parallel connection, then we will see that in case of parallel connection, what are the some different points in case of parallel. Okay, so we will write it as, so we will write it as so these are, yes, so electric connections, and this one is the series connection. So this one is the series connection. Okay, let me shift this diagram here. And let me shift this as like this. Okay, so guys, here you can see that this is the series connection theory, and now we will write it as the parallel connection theory. Okay, so what will be the parallel connection theory? Let us know. Guys, if you are watching this YouTube session live, then please do like this session and share this video among all your friends. Okay, so we will write it as parallel connection. Okay, so we will write it as parallel connection. So we will write it as parallel connection. Yes. So we will write it as parallel connection. Guys, those devices, yes, suppose that yes, so this is yes, so this is the resistance. Okay, so suppose that this is the resistance, and okay, these are two resistances. Okay, suppose that okay, now suppose that these are the two resistances. Okay, and these resistances are R1 and R2. Okay, so these two resistances are R1 and R2, and now so these two resistances are R1 and R2. Okay, and suppose that these two resistances are now connected in parallel. Okay, so this type of connection is known as the parallel connection. First terminal of resistance is connected to the first terminal of the second resistance. Okay, or that will be connected to the first terminal of any other resistance. Okay, so such type of, so in case here you can see that if I current goes through it, okay, if I current passes through this point, I current, okay, then obviously you can see that this I current will be divided like this. Okay, so this I current will be divided like this, okay, so this will be equal to I1 and this will be equal to I2. Okay, this will be divided this will be divided into two parts as I1 and I2. Okay, we all know that we will put the positive sign, here. Okay, yes, we will put the positive sign at this point and the negative sign at this point, because we will put the positive sign at this point and the negative sign at this point, because we all know that positive sign will be kept at the point where electric current enters. Okay, yes, so so there will be some potential difference between these 2 points, okay, like this. Suppose that the potential difference is V1 and the potential difference is V2, okay, and suppose that in case of 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 yes, in case of the net voltage, suppose that in case of the net voltage across these two terminals, okay, across these two terminals like this, is V, okay. Now the voltage across these two terminals will be V, okay. Then what will happen actually? So here we can say that V1 is equal to I1 into R1, okay. So we will write it as V1 will be equal to V1 V1 will be equal to I1 into R1, okay. So this is R1, this is actually R1, okay, and this is actually R2. So this is actually R2, okay. So this is R2. Now we will see that in case of parallel connection, the different values of electric current flows through the conductor, okay. So through the conductor. So here we can say that in parallel connection, in parallel connection in parallel connection different values of I1 and I2 flows through different values of I1 and I2 flows, okay, through the resistances, okay. So this is, but the voltage V1 and V2 are equal, but the voltage across all the devices connected in parallel connection is always equal, okay. So always remember, but the potential difference across all the devices connected in parallel across all the devices connected in parallel is across all the devices connected in parallel is same, yes. It means V1 will be equal to V2, okay, and equal to same and equal to the source voltage, मतलब ये है कि V1 की वैल्यू V2 के बराबर होगी, दैट विल बी इक्वल टू Vs, ओके. So that will be equal to Vs. ये चीज काफी इंपॉर्टेंट चीज है, ये पॉइंट काफी इंपॉर्टेंट है इस तरीके से, ठीक है ना. सो दिस पॉइंट इज वेरी वेरी इंपॉर्टेंट फॉर यू. सो दिस पॉइंट इज वेरी वेरी इंपॉर्टेंट फॉर यू. Okay, so now here you can see that, so now here you can see that now here you can see that v1 will be equal to, yes, i1, sorry, i1, this will be equal to v1 upon r1. Okay, so this will be equal to, suppose that v upon r1. Okay, and i1 and i2, this will be equal to v2 upon r2. Okay, and this will be equal to v upon r2. Okay, now, and I will be equal to, i1 plus i2. Okay, so this will be equal to v upon r, suppose that the total net resistance, this is equal to v. So this will be equal to v upon r1 plus v upon r2. Okay, now 1 upon r, that will be equal to 1 upon r1 plus 1 upon r2. Okay, so this will be equal to 1 upon r2. Now suppose that, so this will be equal to this. Okay, so this will be the total resistance of the circuit if all the elements connected in the circuit are in parallel connection. Okay, so here we can solve it as like this. Suppose that if I give you an example, then obviously you will solve the example very quickly, very wisely. And in this concept there are so many questions which are asked in different examinations. Okay, so in this concept there are so many questions which are asked in different examinations. Okay, so let me write like this. Okay, so these are the connections. Okay, so these are the connections. Yes, suppose that, let me zoom it so that you can see is properly. Okay, so that you can see it properly. So now you can see it properly. Okay, so guys, if you have any problem or any doubt, then you can please tell me. I will try to solve out yes. Okay, so this is all about what? Yes. Okay, so now we will solve some questions based upon the series and parallel concept. Okay, suppose that, okay, suppose that there are two resistances. there are two resistances, three resistances which are connected like this. Okay, which are connected like this is okay, so which are connected like this. So there are three connections, there are three things that has to be connected. So this is A and this is B. This is A and this is B. Okay, and suppose that this is 1 ohm. Okay, suppose that these are the 2 points. Okay, suppose that these are the 2 points, suppose that, and this is 2 ohms. Okay, this is 4 ohm, this is 4 ohm. Okay, and this is 8 ohm. So calculate the total resistance between A and B. So calculate the total resistance between A and B. Okay, so calculate the total resistance between A and B. Calculate the total resistance between A and B. Calculate the total resistance between A and B. Okay, so this is the total resistance between A and B. Suppose that initially here we can see that these two resistances are in series. Okay, so the total resistance will be equal to 8 ohm. So the total resistance will be equal to 8 ohm. Okay, so 8 ohm. It means these 8 ohm and this 8 ohm will be in parallel. Okay, so we will write it as, suppose that the net resistance of these two resistances. Okay, so net resistance of these two resistances of 8 ohm. Okay, and the second 8 ohm, and the second 8 ohm will be like this. Okay, so this will be like this. So this will be like this. Okay, so 8 ohm, so this will be 8 ohm. Okay, and this will be A and B, and suppose that these the equivalent of these two will be equal to, 1 upon R. 1 upon R will be equal to 1 upon 8 plus 1 upon 8, and this will be equal to 1 upon R, and this will be equal to 2 upon 8. Okay, so 2 by 8, and this will be equal to 1 by 4, and R will be equal to 4 ohms. R will be equal to 4 ohms. Okay, so these are okay, so this is actually R dash. Okay, so this is actually R dash. Now we will calculate the 2 ohm resistance. Okay, so now will we calculate that the 2 ohm resistance is already connected with R dash. Okay, so this is R dash. Okay, so now this is A and this is B. Okay, so RAV will be equal to RAV, this will be equal to 2 omega plus R dash. Okay, so 2 omega plus R dash. So this will be the correct answer. So RAV, this will be equal to 2 plus R dash. R means 4. Okay, so this is itna. So this is RAV, and RAV, this will be equal to 6 ohm. Okay, so RAV will be equal to 6 ohm. So this will be the correct answer. So this will be the correct answer. Okay, yes, you can write it as, okay, so this is the solution. Okay, so this is the solution. So this is the solution. So in this way we can solve the various questions. Okay, I will tell you one more thing. That concept of short circuit. In case of short circuit occurs, okay, then what will be the resistance? You will not see in many books. Okay, but you will find it in my class. Okay, and you will find it in my class. So yes, okay. Is it clear to all of you? Is it clear to all of you? Yes. Is it clear to all of you? Now, we will give you another question. Suppose that example number 2, and suppose that uh, resistance like this. Okay. So yes. So these are so this is the circuit actually. Okay. So guys, here you can see the circuit. So this is the circuit. Now you will have to find out the value of the total resistance. Suppose that this is 9 ohm, this is 6 ohm, okay, and this is 3 ohm. Okay, so this is 12 ohm. Okay, now this is suppose that 6 ohm. Okay, and this is 12 ohm. Okay, and this is 18 ohm. So what will be the total resistance between A and B? Suppose that this end is A and this is B. This is B. And also tell me that in which branch the current will be maximum. Okay, and here in which branch the current will be maximum. So what will be the correct answer? Please tell me, how can we solve this question? Please tell, how can we solve this question? This is a very good question actually. So tell me, how can we solve this question? How can we solve this question? Okay. How can we solve this question? Okay, so guys, here you can solve this question very wisely and very easily, because we all know that all these three are in parallel connection. Okay, so all these three are in parallel. Okay, so you will see, you will find them in parallel. Okay, so you will find them in parallel too. Okay, so suppose that this will be R dash. Okay, and this will be R double dash. Suppose that. Okay, so now the circuit will become R dash and 12 ohm plus R double dash will be in series. Okay, so here first of all we will have to calculate the value of R dash. So 1 upon R dash will be equal to 1 upon R dash. This will be equal to 1 upon 3 plus 1 upon 6 plus 1 upon 9. Okay, so plus 1 upon 9, and this will be equal to upon 9 Okay, so this will be equal to 9, no, this will be equal to 18. 18. Okay, so this will be equal to, yes, this will be equal to 6 plus 3 plus 2. Okay, and this will be equal to 6 plus 3, this is 9, and plus 2, this is 11. 11 upon 18, 11 upon 18. Okay, so here the r dash will be equal to, so here r dash will be equal to 18 upon 11, 18 upon 11 ohms. Okay, so 18 upon 11 ohms. So this will be the correct answer. Now here you can see that 1 upon r double dash. So 1 upon r double dash, and this is equal to, and suppose that this is equal to 1 upon 6, 1 upon 6 plus 1 upon 12, 1 upon 12 plus 1 upon 18, 1 upon 18. Okay, so now here you can see that these are three numbers, and which can be calculated as, which can be calculated as 36. Okay, and this will be written as 6 plus 3 plus 2. Okay, so this will be equal to 11 upon 36. Okay, so here r dash will be equal to 36 upon 11, 36 upon 11 ohms. Okay, and now suppose that what, actually it is b, it will be, okay, so it will be, here you can see that, the value, here you can see that the value of RAV. Okay, so RAV will be like this, RAV will be like this. Okay, so this will be equal to r dash plus 12 ohms plus r double dash. Okay, so RAV will be equal to, RAV will be equal to r dash. R dash means 18 upon 11. Yes, 18 upon 11 plus 12. Okay, and this will be equal to 36 upon 11, 36 upon 11 plus 12. Okay, so here this will be equal to RAV, and this will be equal to 54, 54 upon 11, 54 upon 11 plus 12. Okay, so RAV equal to, yes, 54 times 54 plus 12 1 ja 12. Okay, 12 1 ja 12. Okay, so बगम 12 12 and 120, 132. Okay, so this is 132. Okay, so upon 11, upon 11. So here the correct answer will be RAB, and RAB, this will be equal to 546 and 538. So 186 upon 11. Okay, so 186 upon 11. Okay, so this will be the correct answer. So here this will be the correct answer. So this will be the correct answer. Okay, now here you can see that, here you can see that the correct answer is like this. Yes, so this is the solution for that, and you all can see here, the solution of this question. Okay, so such type of questions are very easy, such type of questions are very easy. Okay, such type of questions are very easy. Such type of questions are very easy and understandable. Okay. Okay, so let me tell you one, let me give you one more question. Let me give you one more question actually. Okay, suppose that, uh, suppose that this is the resistance. Okay, suppose that this is the resistance. This is the resistance. Okay, yes. Suppose that this is the resistance. Oh, yes, this is the resistance. And suppose that this is the another resistance, and suppose that this is the another resistance, and suppose that this is the another resistance. Okay, and suppose that this is the another resistance, like this. Okay, and here you can just you can just join them, and just you can join them like this. Okay, so suppose that this is the point P. Okay, so this is the point B and this is the point A. So here this is the point A. Okay, so this is the point A, and now there is another resistance. There is another resistance which is connected to, actually B point is at this point. Okay, so B point is at this point. Suppose that there is another resistance like this. Okay, so this is the another resistance. Okay, like this. Now you will have to calculate the value of the total resistance. You will have to calculate the total resistance if all the resistances are of 2 ohms. Okay, if all the resistances are of 2 ohms. Suppose that these are 2, and these are the also 2 ohm resistance. So what will be the correct answer? So what will be the correct answer? Yes. So what will be the correct answer? Yes. So what will be the correct answer? Please let me know. What will be the correct answer? Guys, here you can see that, uh, here you can see that these two resistances. Okay, suppose, yes, let me remove these things. Okay, all these resistors are of 2 ohms. Okay, so suppose that these two will be in series. Okay, so these two will be in series, and now suppose that these two will be in series. Now then this resistance and the whole resistance, these two will be in parallel. Okay, so these will be in parallel. So these will be in parallel. Okay, now if these two resistances are in parallel, and now here you can see that, so these two resistances are also in series. Okay, and now you can see very easily that this resistance with this green resistance. Okay, so these will be in series connection, and then as a whole these all will be in parallel. Okay, and then as whole will be in series. So this will be the way to solve the question actually. First of all, you will have to identify that which resistance is connected to which resistance and by which connection. Okay, so if you find out the connection between two resistances very easily, or between two or many other resistances very easily, then you can find out the net resistance. Okay, then you can find out the net resistance. So it will be my first priority for you to just tell you that just find out the type of the connection between two resistances, and then try to find, and then try to calculate. Okay, and then try to calculate. So guys, this is the homework for you. Okay, this is the homework for you. Just solve this question, and post your answer in comment box after solving it. Okay, if you are watching this live, then please do like this session and share among this all your friends. Okay, so guys, this will be the correct way to solve the question. Okay, so I think this session is over now. Okay, so tomorrow we will have the same session at the same time. And guys, I will say that just keep doing practice. Okay, keep doing practice and keep visiting us. Okay, sharing, please keep on sharing these videos to other students also, so that a good and healthy environment can be created. Okay, so guys, let's finish this session. Thank you so much. Have a nice day. Bye bye. Take care.